Okay, so hi everyone. So welcome back to the sixth video of this DigitDB playlist. So today in this video we are going to solve this problem from Leetcode that goes by the name count of integers, right? So this problem will definitely use the concept of DigitDB and we will see how. So before starting the video, if you are new to this channel and have not yet subscribed it, then please consider subscribing the channel because there is already a lot of amazing content uploaded here as you can see, right? And I also have created the dedicated playlists for every topic that I am preparing here. And since this video is related to the DigitDB playlist in which already a total of 5 videos is present and this is going to be the 6th video, right? So only if you support me, then I'll be able to upload these kind of videos regularly, right? And I am pretty sure that these videos will definitely be helpful in your upcoming interviews or online assessment tests or anywhere if you encounter in future. So let us get back to the problem now. So the problem reads like this, that you are given two strings num1 and num2, right? So you are given with two strings and also two integers, that is max sum and minimum sum, right? We are given with these four integers initially, and we call an integer x as a good integer if that integer x lies between these num1 and num2. So this is the first condition of being x as a good integer. And the second condition is that the digit sum of that x should lie between this max sum and min sum, right? So what does this digit sum mean actually? So this means nothing but just the summation of all the digits present in the integer x. So if these two conditions are satisfied, then we will call this integer x to be a good integer. And we have to return the number of such good integers present. And since the answer may be large, we have to return it modulo 199 plus 7. And here the definition of digit sum of x is written. That is the summation of every digit present in this integer x. So this is the problem. And in the input also you are given with these four integers initially, as you can see, that is num1 and num2 and this minimum sum and the maximum sum. And also you are given with these two examples here, and these are the constraints here. So as you can see that this num1 and num2 can go up till 10 to the power 22, which is very high, and also this minimum sum and maximum sum can go up till 400, right? So these two are the constraints given. So if you have not yet studied DigitDB before and you are directly watching this video, then I will highly recommend you to watch this first video at least in this series, because then only you will be able to grasp the concepts of the states that I will define in this video. But if you are already familiar with the basic concepts of DigitDB, then you can definitely watch this video right now. So let us now try to think why this is a DigitDB problem. So as I have told you in the previous videos that for a problem to be a DigitDB, there are three indicators. So the first indicator will be that the constraint given will be very high, and as you can see that this num1 and num2 values can go up till 10 to the power 22, which is very high. So that's why this is a DigitDB problem. So this is the first indicator. The second indicator is that you'll always be given a range. So that range might be given to you directly or indirectly, but anyways you will be given. So if you look here closely, then the range here is not given directly, but if you look closely, then you will realize that whatever integer x you have to choose, it will always lie between this, that is num1 and num2. So that's why this num1 and num2 are nothing but the range, that is the extreme points of the range. That is, this num1 will be my leftmost point of the range and this num2 will be my rightmost point of the range, right? So that's why this num1 comma num2 will be my range here. And the third indicator is that in the output you always have to print an integer denoting the count of only specific integers in that range. So the same thing is also described here to return. So that's why this is a DigitDB question, because it is satisfying all these three conditions. So if you look closely here, then in the first example the value of num1 is 1 and the num2 is 12, and minimum sum is 1 and maximum sum is 8, right? And the expected output here is 11. So why the expected output is 11? Because see, since I have already told you that the range here will be nothing but from num1 till num2, right? That is from 1 to 12. So this is the range here, that is from 1 to 12, right? And if this is the range, then there are a total of 12 integers present in this range, that is from 1 to 12. And since we want to return the count of only specific integers present in this range, for which the digit count will lie between this minimum sum and maximum sum, that is from 1 to 8 inclusive, right? So that's why if you look here, then each and every integer present in this range from 1 to 12 except 9 will satisfy this criteria, because for the integer 9 the digit sum will be nothing but 9 only, which lies outside between 1 to 8. So that's why 9 will not be a part of it. But except 9, each and every integer present in this range from 1 to 12 will have a digit sum lying between these, that is from 1 to 8. So that's why the expected output for this example is 11, and the same thing will be done for this example as well. So since the num1 here is 1 and num2 is 5, so it means that our range is nothing but 1 to 5, that is a total of 5 integers. And since the minimum sum here is 1 and maximum sum is 5, so that's why for each of the integers present here, that is from 1 to 5, the digit sum will always lie between this range, that is from 1 to 5. So that's why the output here is nothing but 5, and that's why we are returning 5. So I hope that you have understood this problem till now, and let us now try to go to the blackboard and see how we will approach this problem and what concept we will apply. So let us go to the blackboard now. So in the input you will be given two strings, that is num1 and num2, which will denote nothing but the extreme points of the range, right? So it means that you will be given the range indirectly like this, and you have to calculate the total number of integers present in this range that will be good integer. And what was the definition of an integer for to be a good integer? So it must lie in this range. This is the first condition, and the second condition was that the digit sum, right, the digit sum should lie between minimum and the maximum value given in the input, right? So that's why we have to return the count of total good integers present in this range. And we know very well that what we used to do in these kind of problems, what we do is, instead of calculating the value directly for this range, we calculate it first for the rightmost part and then for the leftmost part, right? So that's why if we try to solve it for the rightmost part first, then what it will do is, it will simply calculate the total number of good integers present in this range, that is from 0 till num2, right? And the same thing we will do for one less than the leftmost part, that is, it will also calculate nothing but the total number of good integers present in this range, right? And after calculating both of them and subtracting, it will basically give us the total number of good integers present in this range, which actually we want. So that's why we apply this prefix sum analogy here. So once this thing is clear to you, let us move forward now. So consider this example that I have considered by myself. So in this example, the range given is something like this, that is, the leftmost point is 741 and the rightmost point is 78,561, and the minimum sum expected is 18 and the maximum sum expected is 27 for the digit sum, right? So that's why, since we know that we have to call each of these functions separately, that's why we will try to derive the logic for any one of them, and the same thing will be applicable to the other function as well, right? So that's why here what I'm trying to do is that I'm trying to solve the function for the rightmost part only. So what we have to do initially is that, since initially this two parameters are given in the form of a string already, so we don't have to convert the integer to string now, because they are already given in the form of a string, right? So that's why let me denote the same here. So they are already given in the form of a string, so that's why you don't have to convert it explicitly, unlike before. This is the rightmost limit, right? And this is nothing but a string only, right? So this is a string, and if I mark the indexes here, so this is the 0th index, 1st, 2nd, 3rd and 4th, right? And that's why the total size of this integer is nothing but 5, right? So this is one thing, and we know what we have to do. So since a total of 5 digits are present in this, so that's why what we will do, we will construct 5 independent blocks here, right? And this will be my 0th index, this will be my 1st, 2nd, 3rd and 4th, right? So we already know these things. I don't have to describe this in much detail, I guess. And once we will cross this path, that is we will reach the fifth index. So in that we will conclude that our work is done, that is the required integer is constructed, right? Since in the problem for an integer x to be a good integer, it has to satisfy two conditions. That is, the first condition was that it should lie between the given range, that is between num1 and num2. So this will be satisfied automatically if I set this n to be the rightmost range here, right? And the second condition was that the digit sum, let me write here, the digit sum of that x should lie between this maxi and minimum value given in the question itself, right? So that's why what we will do is, when our whole integer will be found by the end, we will simply check the digit sum. So if the digit sum lies in the given range, that is the expected range, it means that the given integer is formed successfully and the digit sum lies in that range. So that's why we'll return +1 in that case. So to do this, we have to start building our integer from this side and going all the way till this side, that is from MSB till LSB, right? So let us start doing it. Since we know that, first we have to fill this block, that is the 0th index. And in order to fill this block, we have few choices. So what I can do here is, I can fill it with either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, right? So these are the possible choices for this index, because if I try to fill it with anything, let's say 8 or 9, then what will happen is that the entire integer will become greater than this. But we know that we cannot cross this limit because this is the rightmost limit, that is the num2 given. So that's why we will never place 8 or 9 here. This will not, never be true. So if I write the options here, then here what I can fill it with, I can fill it with 0 or 1 or 2 or 3 or 4 all the way till 7, like this. And this will denote our first case and this will denote by second case. So what do I mean by cases here? So if I select any integer from this first case, then for the remaining blocks the condition of type will be false, right? But if I select this integer from the second case, then for the next block also the condition of type will remain true. So we know these things already, so that's why I'm not going in depth much here. And since we do not have any restrictions now in order to choose any integer from these two cases, so suppose I decided to pick 7 here. So if I pick 7 here, then I will write 7 on this block and then I will move to this next block. And since I have chosen 7 here, which is actual the digit present in this string at the 0th index, it means that the condition of type for this block will also remain true, right? So initially it was true, and here I have chosen the upper bound, so that's why it is also true for the next block. So now I'm standing on the first index, that is this, and here the digit present on this string is 8, and since the condition of type is true, so it again means that for this first block or the first index, I can choose any digit present between 0 till 8 only. That is, I cannot choose 9. That is, except 9, I can choose any digit here. So if I write the possibilities, then I can choose anything like this. So I can choose anything in this range. And again, I can say that since the condition of type as of now, what can I do is, I can again divide this range into two cases like this. Because if I select any integer present in this range, then it means that for the next block onwards till the last block the condition will remain false or for the type. But if I select 8, then what will happen is that whatever integer has been formed till now, it will actually match with the original string, and that's why for the next block also the condition of type will remain true and we cannot select anything freely between 0 to 9, right? So suppose here I decided to pick 8. So if I pick 8 like this, then what will happen? So again I picked 8 and then I will move to the next block. And now we know very well that for this block also the condition of type will remain true. That is, we can only select now from 0 to 5. So again if I write the possibilities here, so here I am allowed to choose anything in this range, that is from 0 to 5. And again I can divide it into two cases like this. So if we choose anything from this range, then for the next block onwards the condition of type will get false. Otherwise in this range the condition of type for the next block will get true, right? So suppose now what happens is that I decided to pick the second integer or the second digit. So if I pick second here, then the form digit till now will look something like this, that is 7, then 8, then 2, and then I'll move to this next block. And since here I have picked 2, which actually belongs to the first case, then it means that the condition of type will automatically get false for the rest of the blocks remaining, right? So that's why when I will move to this block now, actual digit that is present on the third index here is 6. But since the condition of type is false now, so it means that whatever digit we can fill it with here at the third index does not depend on this now. It means that I can fill it with anything from 0 to 9, right? So if I write here, so these are the possibilities now, that is from 0 to 9, right? And again I have the choice to select anything in this range. So suppose I decided to select this 4, and if I select 4 here, because there is no restriction, right, I can select anything. So that's why I have decided to select 4 here. So if I select 4 here, then again I will move to the next block, and the condition for this block has already turned false, right, for the typed variable. So again that's why I can say that I have a total of 10 choices here, that is from 0 to 9, and this is nothing but just a one single case. And again I have to select one digit in this range. So suppose I decided to select 2 here, so I selected 2, and when I will select 2 at the fourth index, I will call the function again and will move to the next iteration, that is the index value will get increased by 1. So in this way I will reach this fifth index here, and when I will reach the fifth index, then I will simply compare that if the value of current index is equal to the string size. So if it is equal, then it means that our whole integer is formed successfully. But should we return true now, or should we contribute +1 to our answer? So we have to check whether the formed integer, the digit sum of that integer actually lies in the expected range or not. Because we know that the expected range is what? The expected range is something like this, that the digit sum for the formed integer x should be greater than or equal to the minimum sum, let's call it mini, and it should be less than or equal to the maximum sum, let's call it maxi. So that's why it has to lie in this range, and if it is true, then only we will contribute +1 to our answer, that is the formed integer satisfy both of the conditions to be a good integer. So since here the formed integer is something like 7, then 8, then 2, then 4, then 2, so 7, 8, 2, 4, 2, right? So if I write here, then the formed integer is something like 7, 8, 2, 4, 2. And what is the digit sum of this? So it is nothing but 7 plus 8 plus 2 plus 4 plus 2, right? Which is nothing but 15 plus 2 plus 6, which is nothing but 17 plus 6, which is nothing but 23. So that's why the digit sum for this is nothing but 23. So that's why before returning true, we will simply check if this 23 lies in the given range or not. So if you remember, then what is the minimum and a maximum value expected in this example that I have considered? So I told you that the minimum sum expected is 18 and the maximum sum expected is 27. So it should lie between 18 to 27. So since our formed digit sum is 23, so clearly this 23 is greater than or equal to 18 and less than or equal to 27. That is, it lies in the given range. So that's why I can say confidently that this formed integer is satisfying both of the conditions to be called a good integer, and that's why this is a valid formed integer and it should contribute +1 to our answer. So this is the whole logic here, and we will do the same for each and every integer present in this range, that is from 0 till this n. We don't have to worry about this because by giving each of the choices in each recursive call, it will actually explore each and every possibility, that is each and every integer present in this range, and whatever good integers will be there, it will count them as good and contribute +1 to the answer. So let us now try to discuss what states will be used here. So clearly, since we are moving each time forward by one step, so that's why I can say that my first state will be nothing but this index value, right? So this index will be my very first state, and the second state, as you might have guessed, will be nothing but this type variable. So this will help to decide whether we can fill for a given index from 0 to 9 or not. So if the condition is false of the type variable, then it means that we can definitely fill it with any value from 0 to 9. So that's why in this, for this range, the condition of type was false. So that's why we had the choice of filling everything from 0 to 9. But if it is not the case, that is the condition of type is true, then it means that we can only fill it with values starting from 0 and going till the digit present in the string actually. So that's why this will be my second state. And since by the end we reach at this point, we want to know if the digit sum is actually lying in that range or not. So that's why we should have the record of the digit sum. So that's why what we will do is, initially we will say that the digit sum is 0 because no digit has been chosen yet. And when we will be choosing this 7 and will be moving to this index, that is the first index, then I will say that the digit sum is 7. And then again I am choosing 8 and I am moving to the next index, so I will again say that my digit sum is this 7 plus 8. And then again I will move to this index, then I can say that my digit sum is nothing but 7 plus 8 plus 2. And again I will move to this index and I will say that my digit sum is nothing but 7 plus 8 plus 2 plus 4. And finally I will reach this point including this last digit that I have chosen for the fourth index. So that's why to have this record, I will use this third state here. So this third state will be holding the value of the digit sum. So let's call it sum only. So this is the whole logic that will be required in order to solve this problem. I hope you got this. So before moving to the coding part, I want to tell you one thing. So since now we know that we have to solve it for both the left part and the rightmost part, right? So first we'll be solving it for the rightmost part and then we'll be solving it for the leftmost part. But since in the input you are given this num1 and num2 and we have to use this num1 and num2 in the form of a string, which is actually given in the form of a string, which is a good thing for us, right? So that's why we are not worried about this num2. But this num1, so see, we are actually using num1 minus 1 here and not num1 actually, right? And if I show you, then in the constraint you can see that the value of num1 and num2 can go up till 10 to the power 22, right? So that's why when you will try to convert this string into an integer or a long value and reduce it by 1 and again convert it into a string in order to use that num1 minus 1 value, then it will create problems. So you cannot convert it directly. That is, you cannot convert this given num1 into a number and again into a string. So that's why what we will do instead is that we will not convert this num1 string into an integer in order to reduce it by 1. We will simply play with the string only that we are given in order to reduce this by 1, right? So that's why whatever num1 string will be given, we will not convert it into a number in order to reduce it by 1. Whatever string will be given, we will simply play with that string only, starting from the backward side, that is the last index, and going all the way till the 0th index in order to decrease it by 1. So it will be nothing but a simple logic only that we'll be doing in order to convert this num1 to num1 minus 1 string. I think it will be very good for us if we move to the coding part and write this recursive solution, and after writing this recursive solution we will further see how we can memoize it. Let us move to the code editor now. So initially, as I have said you that this num1 and num2 is given in the form of string and this num2 is good to go, but we have to convert this num1 to num1 minus 1 actually, right? And we won't be able to do it directly. So that's what I will do instead is I will call a function, let's call it subtract 1, right? And I will simply pass this num1 and whatever it will return, it will be actually this num1 only that has been reduced by 1. So first we'll be doing this, and in order to do this let us start writing this function here. So it will be very simple. So let's call this function as subtract 1 as written below, and a string will be passed like this. So n will be the size for this string, right? And the index that we will start initially will be the last index, that is n minus 1, and until and unless the current index is not 0, so I will simply check if the current character is greater than 0 or not. So if it is greater than 0, then it simply means that I have to decrease it by 1, right? And I will break, right? But if it is not the case, then it means that the current character is 0, and if the current character is 0, then I will simply set it to 9. and then do a I minus minus. And after this is done, we will simply check the 0th index is actually the 0th character or not. So if it is 0th character and the string size that has been formed is greater than 1, so it means that from whatever index the first digit will be 1, we have to extract from that index, right? So that's why I will return this, right? But if it is not the case, then it means that I simply have to return whatever string has been formed till now, that is s only. So by writing this function and calling this function, it will simply convert the given num1 to num1 minus 1, which will be our nothing but the leftmost limit, and the rightmost limit is already this num2, so that's why we are not worried about that. And since we want to check for this minimum sum and maximum sum every time, whether the integer that has been formed lies in this range or not, so that's why here I am declaring these two variables globally so that I don't have to pass every time in the function. Let's call it as mini and maxi, right? So here I have declared mini and maxi, and I can say that this mini will be nothing but this minimum sum, right? And this maxi will be nothing but my maximum sum, like this. So once this is done, I will actually call my function now for the rightmost part, that is in order to calculate the answer from 0 till num2. So let's say it as answer for rightmost part, like this, and the name of the function will be f, and I'll be passing this num2 like this. And the same thing we will do for the leftmost part, right? That is this, right? And after both of this has been calculated, we will simply return. And what we will return? I will return this, that is the answer calculated for the right part minus the answer calculated for the left part, like this. So let us start writing our main function now. So the name of the function is f, and the first argument is a string s, and now we know that what things we have to pass here. So here I also have to pass the string, that is this will be num2 and this will be num1, so sorry for this. And now the second argument will be the index, which is 0 initially, and also the value for the typed variable will be initially true, right? That is 1. So let me write these two arguments here. So the second argument is this index, and the third argument is this typed variable. So we know that what will be the base case. So if this index becomes equal to the string size, so we will simply check if the digit sum actually lies in the given range. That is, if the digit sum is greater than or equal to mini and this digit sum is less than or equal to maxi. So if it is true, then it means that we will return 1, otherwise we will return false or 0. So you can write this in one line also, like this, that is this, right? So you can write it like this also. So let me pass this sum variable here as the fourth argument. So initially the current sum will be 0, so this sum here. But if it is not the case, then it means that we are somewhere in between. So we have to decide with what digits we can fill it with. So the lower bound will be 0 as always, and the upper bound will be decided by the value of type. So if the type is true, then it means that we can fill it with anything from 0 till the given digit actually present in the string, otherwise 9. So now if I start iterating here in the digits, that is from lower bound and going till this upper bound, then since we are always allowed to choose any one of the digits here, so that's why I'm not placing any extra condition here. I will simply add it to the result, right? So the first argument will be this string only. This index value will get increased by 1. The typed value will depend like this as always, right? And what will be the value of this sum? So whatever sum has been present till now plus the value of the current digit, that is this. And at last I will simply return this result. So let me declare this result variable here like this. So in this way our work will be done. And since in the question it was written that the answer may be large, so you have to return it modulo 1e9 plus 7, right? So let me declare this mod here. So this will be 1e9 plus 7 like this. So that's why after adding every time we will simply take a mod also like this. So here also you can take the mod if you want. And since we have used this mod here, right, so it might be possible that the answer that we have calculated for the right part, theoretically it should be greater than this leftmost part, then only the answer will be positive. But since we have used this modulo condition here, so it might be possible that this answer for left part becomes actually greater than this rightmost part. So to make sure that this thing do not happen, what we do is that, so this is a simple trick that we use in competitive programming also. So we add this modulo here, and after it again take this mod. So by doing it, we ensure that the answer for right, even if it is less than the answer for left, then the overall answer will be the same as required. Let us now try to run and see if we are correct or not. So there is a small mistake here, I guess. Sorry, instead of passing these arguments here, I should have passed it there only. So my bad. So now I think we are correct. Let's again run it. As you can see that we are correct till now, but I'm not going to submit it now because I want to memoize this solution, right? So in order to memoize it, we have to declare the DP table here. So let me declare it now. So since a total of 3 states are present here, that is this index, tight and this sum. So that's why I will use 3 states like this. And I hope you know how to memoize it. So I will simply give this check and see if this is not equal to -1. So if it is not equal to -1, then it means that I have already stored this value. So I will simply return that. And before returning it here, I will simply store it like this. So this is nothing but idx, this is nothing but tight, and this is nothing but this sum. Similarly for this is idx, this is tight, and this is sum. And similarly for this. And let us now try to think what will be the size for each of the states. So since this is nothing but tight, which is a boolean value, so it will be 2. And since the maximum value that this string can have is 10 to the power 22, that is a total of 23 digits, right, which will be marked from 0 till 22. So that's why in order to access this 22nd index, we have to declare a size of 23 at least. So that's why it will be 23. And now let us try to think what will be the maximum size possible for this current sum. So since the maximum value here is 10 to the power 22, so if I write, then the maximum value is 10 to the power 22, right? That is 1, and then a total of 22 such zeros. So if I write here, so it will look something like this. That is 1 and then remaining 22 zeros, right? So since we want to decide the maximum value for the sum state, so for this integer, the sum value will be nothing but 1 only, which is clearly not the maximum one. So if you want to decide the maximum value, then what we will do is, I will simply subtract 1. So if I subtract 1 from this, then what we will get? We will get something like this, that is 0, and remaining 22 values will be nothing but 9 only, right? So the remaining 22 values will be 9. And now if you try to take the digit sum of this, then it will be equal to nothing but this 9 into 22, right, which is nothing but 198. And in order to access this 198, you must declare a size of 199. So that's why the size here will be nothing but 199. And let us also do a memset here for each of the functions. So like this, and similarly for this. Now I think I have written the complete code. Let us now again run to see if we are correct or not. As you can see here, we are correct. And let us now try to submit it finally and see if we are completely correct or not. So as you can see that our test cases are getting passed completely and the solution is accepted now. And this is the code that we just wrote, and I explained you each and everything in very detail, what is the logic behind all this, right? So yeah, thank you so much for watching this video till this point. If you really think you understood something new that can be helpful in your upcoming interviews, then please consider subscribing this channel and liking this video and sharing it with your friends who need to watch the series from the beginning. So yeah, thank you so much for watching these videos. Thank you.